potential energy versus kinetic energy. We're going to first focus on potential energy. Systems or objects with potential energy are able to exert forces, exchange energy as they change. Potential energy is energy due to position. So depending on the position, the potential energy changes. So basically we're talking stored work. Some of this energy is transferred to the ball to do work. When it's transferred, it's changed into kinetic energy, energy of motion. So while the block is just sitting in the hand, that is potential energy. The energy has not been used for anything yet. A block suspended above a table has potential energy. If it's released, the force of the gravity moves the block down to a position of lower energy. So basically saying the higher the object is, it increases the potential energy. The lower it is, the lower the potential energy. So a rock sitting on the ground has a low amount of potential energy. A rock sitting on top of a mountain has higher potential energy because it has a higher elevation. So therefore, we look at the term gravitational potential energy. So it describes the energy of an elevated object. You will see this as GPE, gravitational potential energy. You can solve for potential energy of an object. So E is the energy, P is for potential. M is for mass of the object, G is for the gravity, and gravity, which Newton has found, it is 9.8 meters per second squared. So that is a given. Anytime you have to use gravity, you're always going to use this number. And then you have the height of the object. So if the object is not raised at all, it'll be 0. And of course, going back, that is measured in our meters. And because we are looking for potential energy, when we solve our answer, we are going to write our answer in the units of joules, as we referenced before. So looking at an example, potential energy practice problem. So calculate the gravitational potential energy of a 95 kilogram rock at the top of a 45-meter cliff. Now here it shows you the equation for potential energy is your mass times your height times your gravity. You will be given a formula sheet that has triangles. When you look at a formula triangle, it is broken into parts to help you solve the problem. So you have potential energy, and the equation is mass times gravity times height. The nice thing about this equation triangle is it is useful when you, especially when you are asked to solve for different items of the equation. If you're solving for potential energy, you're going to cover up, and that doesn't cover it up. Let's go back here. Okay. Back here. When you take the square, if you would cover up the M, imagine that's covering it up, that's what you're solving for. So that is what you would solve for to find the potential to find the mass of the object if you're given the potential energy and the gravity and the height. Here we are just solving for potential energy. So we look at what the equation is and what is given. We look at the problem and you have 95 kilograms. That is our mass. So we list it here. It says at the top of a 45-meter cliff. That is our height. Now you look at the equation, gravity is missing. But like I said before, we know that it is 9.8 meters per second squared, so it is a given. So you plug it into the equation and you multiply 95 kilograms times 45 meters times 9.8 meters per second squared, and you get the answer of 41,895 in joules, because we are using units of energy. So that is our answer. You'll get more practice doing those later. Kinetic energy. This is energy of motion. So an object in motion is kinetic energy. Kinetic energy can easily be converted into potential energy and vice versa. So here we have the equation of kinetic energy. Again, K is for kinetic, E is for your energy, and it's half of the mass multiplied by the velocity squared. So this V is your velocity or speed of the object, mass of the object. And you have to do the half of that to get your answer. So looking at a kinetic energy problem. This is calculate the kinetic energy of a bicyclist traveling at 11 meters per second. The total mass of the cyclist and the bike is 74 kilograms. Again, when you look at an equation triangle, which you will be adding these to your paper, that you will get is kinetic energy is solved by multiplying half of the mass multiplied by your speed squared. So here's our equation written here in this manner. Now the mass that they give us is 74 kilograms, so that goes here. And the speed they give us is 11 meters per second squared. 11 meters per second, not squared. So we plug that in to the equation. Kinetic energy equals 1/2, 74 multiplied by 11 meters per second squared. So with any math problem that you do everything in parentheses first. So you take half of 74, which gives you 37. Then you multiply that by 11 meters per second, but that's squared. So 11 squared is really 121. So your answer is 4,477 joules. Again, because we are solving for energy. So key thing is to do the half first and square it first, and then multiply it second. Kinetic energy. The amount of kinetic energy an object has equals the amount of work the object can do by exerting force as it stops. So if you look here, a moving skateboard and a rider are going in this direction. You have a force of 500 newtons applied for 10 meters over a distance, and it brings the skateboard rider to a stop. So the work done is your force multiplied by your distance, and that gives you 5,000 joules. And we will visit work again a little bit later. So this is just a little bit of taste of it.